So in our previous video, we learned about direct variation, where as one variable increased, the other also increased. Well, today we're going to be talking about inverse variation. Now the key here with inverse variation is that as one variable increases, the other is going to decrease. It's going to be very similar to the process to solving these problems as what we did yesterday. But let's start out with just setting up an equation. Here it says the speed of a bike varies inversely with the number b of back gear teeth on the rear wheel. Write an equation that expresses this relationship. Remember yesterday when we talked about that phrase, and we said whenever we heard that phrase is directly proportional or varies directly, we said that means it equals k times something. Well, as you can see from our equation up here, when we have something that varies inversely, the equation is going to be y equals k divided by x to some exponent. So here I hear the phrase that it says it varies inversely. Anytime you see that phrase, inversely means we're going to have k divided by something. So it's going to be s equals k divided by b. Now this would be the proper way to write it. Please don't write it like this. Sometimes even in your own work, when you do that, you end up mistaking that for a minus. So the proper way to write it would just be to write it as s equals k divided by b as a fraction. So let's look at the next one. It says the number of units u in a length varies inversely with the length L of the unit. Well, again, we see that phrase varies inversely means k divided by something. So it's going to be u equals k divided by L. Pretty basic. Now, in a lot of these problems, we're going to be dealing with this type of story problem, dealing with the law of the lever, which basically states that, so just some terms here, is that in order to balance a seesaw, another person must sit a certain distance d from the pivot or fulcrum of the seesaw. They say the distance is inversely proportional to his or her weight. So the distance you have to sit to balance a seesaw or teeter-totter out is inversely proportional to the weight. Meaning that as the heavier a person weighs, so as the weight increases, the distance from the fulcrum is going to decrease. So what that means is that, like it says here, this means a lighter person can balance a seesaw by sitting farther from the pivot. So in other words, as the weight decreases for a lighter person, the distance from the pivot is going to increase. Or, like they say, a heavier person can balance a seesaw by sitting closer to the pivot. So as the weight of a person increases, the distance from the pivot is going to decrease. Let's look at this example. By the way, you want to make sure that you get that formula in your notes, because in your homework assignment they're going to be talking about seesaws, and so you're just going to want to make sure that you know this formula. The distance is inversely proportional to the person's weight. So when they say something like this, Ashley and Sam are trying to balance on a seesaw. Suppose Sam, who weighs 42 kilograms, is sitting 2 meters from the pivot. Ashley weighs 32 kilograms. How far away from the pivot must she sit to balance Sam? Remember the process that we did yesterday. Our first step is to come up with our general equation, which we already have. Think back. What was the second step? What was the next thing we had to do? We had to find out what k was. Well, in order to find out what k is, I need to know a distance and a weight. Well, they give that to us here. It says, suppose Sam, who weighs 42 kilograms, is sitting 2 meters from the pivot. There's our distance, and here's our weight. So I'm going to say when the distance is 2, we have k divided by 42. So to find out what k is, we cross multiply, or multiply both sides by 42, and we get a value of k, which is 84. Now that I know what k equals, I can come up with my specific equation for this scenario. Now this only works for this scenario with when Sam is sitting on the teeter-totter. As soon as Sam gets off and someone else gets on, there's going to be a brand new value for K. So don't think that in all your assignments today that K is going to be 84. It's going to be different depending on the weight of the person that's sitting on the seesaw. Okay, so now I know for this particular equation, it's going to be the distance equals 84 divided by W. So Ashley, who weighs 32 kilograms, to figure out how far away she needs to sit from the pivot in order to balance it out, we just put her weight in there for W. So it's going to be 84 divided by 32. When we divide that out, you get 2.625 meters. Okay. Let's look at another one. Suppose Carrie weighs 34 kilograms. So now Sam has gotten off, and now Carrie's getting on. And Carrie weighs 34 kilograms and is 1.8 meters from the pivot of seesaw. If Madison weighs 38 kilograms, how far from the pivot should she sit to balance Carrie? Okay, it's the same thing as what we did before. So we're going to be using this formula. D equals K divided by W. I want you guys to take it from here. Just remember the 4 steps. Look back at the previous one. We already did the first step here together. D equals K divided by W. So I want you guys to try this problem out. So pause the video and hit play when you're ready to check your answer. Okay, so you should have guessed that these are the 2 numbers that we're going to use to find K. So the distance is 1.8 equals K divided by 34. Multiply both sides by 34. You should have gotten 61.2 as your answer. So now we come up with our variation equation, which in this case is D equals 61.2 all divided by W. So now to find out the answer, it's going to be D equals 61.2 divided by Madison's weight, which is 38 kilograms. And when you do that, you get a distance of 1.6 meters. Okay. Now, just like, this only makes sense, but just like yesterday when we were dealing with direct variation, sometimes we could say something very directly as a square of something else. Same thing with inverse variation. Now, we haven't dealt with exponents yet, but that's what we're going to look at now. And we want to make sure, too, that you also get this formula written down. This formula is referring to light intensity, where the light intensity is inversely proportional to the square of the distance from the light source. Now you're going to have some questions in your homework assignment dealing with this. Let's look at the story problem. It says, suppose the intensity of the light 4 meters from the light source is 40 lumens. A lumen is just measured as a measurement as the amount of light falls on a 1 square foot area that is 1 foot from a candle. So you'll see oftentimes when you buy light bulbs, you'll see the light is measured in lumens. So find the constant variation to determine the intensity of the same light 6 meters from its source. Okay, so we're going to go through all those steps that we've been doing, but remember this time that intensity, the light intensity, the lumens, is inversely proportional to the square of the distance. So again, to find out what K is, we need to know a distance and a light intensity. We know that 4 meters from a light source, the lumens is going to be 40. So I would say 40 equals K divided by 4 squared. You know, 4 squared is 16. So I multiply both sides by 16. I get a value of K here that is 640. Next, I come up with my specific equation. This is for just this scenario, so it's not always going to be this for other problems dealing with light intensity. It's just for this one. So our specific equation, or the variation equation, would be 640 divided by d squared. So now all I have to do is put a value in for d. So they say find the constant of variation and determine the intensity of the same light 6 meters from the source. So I would take 640 divided by 6 squared, or 36, which gives me 17.8 lumens. Would be my answer. Okay, why don't you take a second now and try it for this next story problem. It says, suppose the intensity of light 6 meters from a light source is 30 lumens. Find the constant of variation and determine the intensity of the same light 9 meters from its source. So remember, this time again you're going to have a different value for K, since we're looking at a different light. Because we have the intensity of light is 6 meters from light source is going to be 30 lumens. So go ahead and work this one out on your own. So pause the video and hit play when you're ready to check your answer. Okay, so let's check your answers here. So what you should have done is, first step, to find K. We need to know that we need to know a distance, we need to know an intensity, so that's what we have here. So 30 equals K divided by the distance squared. 30 equals K divided by 36. We multiply both sides by 36. When you do that, we get a value of K, which is 1080. So our specific equation is that I equals 1080 divided by the distance squared. So now to find our answer, we know that we use the same light, 9 meters from its source this time, so it's going to be I equals 1080 divided by 9 squared, or divided by 81. And you do that, you get 13.3 lumens. Okay, so hopefully you can see that these problems are very similar to what we did yesterday. Just remember, anytime you see that phrase, is inversely proportional, it means K divided by something. And remember, if you hear the phrase, it's directly proportional, it means K times something. That's the difference between what we did yesterday and what we did today. So good luck on your homework assignment.